Good afternoon, everyone, and welcome to those of you watching online as well. Just the normal housekeeping. Can you put your mobile devices on silent? And if you're tweeting, the hashtag is sharedworld. And I have got Twitter today, so if you are watching online, please do send me any questions via Twitter and I can relay them into the room. And for those of you who are in the room, thanks for coming on such a glorious day. I was a bit worried we'd be reduced numbers, so I think that shows how passionate the Oxford community is about our global oceans. And I'm thrilled to introduce the second in this term's seminar series on how we can make our oceans sustainable. It's a new programme that started in October, and the three directors of the programme are here today. Richard Bailey will go first, then Alex Rogers, and then Catherine Redgwell. And they've said that in summary, Richard is the Matrix reloaded version of the ocean. Alex is nicking people, and Catherine is fish don't know any borders. So that's what's in store today. Thank you.
Thanks very much. I'm not sure I can live up to that Matrix reference, but I'll do my best. Well, thanks for coming, and thanks for the invitation to the Martin School, and also for instigating this programme and supporting us so well over the next 5 years. We're very grateful to that. I should also thank our wonderful array of collaborators. We couldn't do this work. I hope you'll get a sense over the next hour or so. This is a highly interdisciplinary project, and we call on the expertise of a whole range of people and a whole range of organisations that we're working with globally. Also to mention the hard-working staff beyond us three, of course, who actually do most of the hard work. So I think most good ocean talks start with a view of the sunlight coming in through a deep blue ocean. Beyond that, I think it's also worth underlining just how large and important the ocean is. It's 1.3 billion cubic kilometres, which is vast. It provides more than 90% of the living space on the Earth. Also, it's absolutely vital for the health of the Earth system, so lots of the geochemical processes that keep life alive on the planet operate through the ocean. We get about half of our oxygen comes from the ocean. If you look at carbon, for example, we all understand that carbon is a vitally important component of the Earth system. Look at the cycling of carbon through the ocean. The atmosphere has about 860 gigatons of carbon, and that's compared to about 38,000 gigatons that's resident in the ocean. So the ocean is a reserve of carbon, and its behaviour is fundamentally important to climate on a whole range of timescales. But also, of course, it's a store of biodiversity. We get a lot of what we call ecosystem services. So what does the ecosystem provide to us? We can think it absorbs about a third of the CO2 that we produce from fossil fuel emissions. There's a big drive for the blue economy. How can we earn money and establish resource from the ocean? It provides an enormous amount of food for humans. 20% of the protein for 2 billion people comes from the oceans, and it's a majority protein for more than 1 billion. So it's a vitally important part of the Earth system. So what are some of the challenges for keeping this system and maintaining it in a sustainable state? To some extent, we are the custodians of the ocean. We have a massive effect on it now. Part of the difficulty is that we know an awful lot about the ocean, but we still don't really know enough. So there's big gaps in our knowledge. There's vast swathes of the ocean that are still unexplored. We need to know more about the fundamental behaviour of these systems. Another challenge to sustainability of the oceans is human impact. We'll hear more about this in the following slides. We damaged the habitat, there's acidification, there's a whole range of climate change issues. And these are things like overfishing, which I'm going to talk about in more depth, no pun intended, over the next few slides. The oceans are difficult to understand and certainly difficult to govern for these reasons, also because they're highly complex social ecological systems. Blue growth, I've mentioned before, is on the rise. The markets associated with oceans are highly globalized. Poverty and inequality are linked to behavior of ocean systems. For example, about 90% of fishers live in the developing world countries. So these are very, very interesting, complicated, difficult systems to try and understand and try and deal with. And that inevitably leads on to difficulties with governance. These are especially in the high seas, and you'll hear more from Catherine on this specifically. So very, very difficult governed, very interesting, very important, very big difficult systems, highly interconnected problems. A lot of the problems that the oceans face are exacerbated by population increase, so human pressure is amplified, of course, by population growth. We're expected to hit something like 10 billion by 2050. That will impose many more pressures on the ocean systems. So this little cartoon here is a cartoon that kind of summarises the main features of our program, and you'll hear about these individual components. You'll see that there's a legal. See if I can get this pointer to work. Okay, so we have some interest in the legal systems. We have an interest in understanding and collecting together information about biodiversity and about sensitivity of the environmental system to perturbations and impacts. Fisheries is a big part. One of the biggest impacts we have on the global oceans is through fishing. Marine mining is becoming a very important issue in the oceans. And then enforcement. How can we watch what's happening on the oceans? And then try and enforce these sort of legal procedures is an extremely difficult and timely problem. So you can see, hopefully you'll see by the end of the talk that these things are all very much interconnected. And the reason we have this project that's set up the way it is because we need people to work together on these different components, but also have a more holistic view to try and tie together these different threads. So, where to start? I'm going to focus on fisheries and on fishing and the problem of overfishing. I thought I'd start here, going back 2,000 years or so ago, because this is it's a very interesting picture for a whole range of reasons. This is a Roman depiction of fishing in the Mediterranean. The Romans are really amongst as far as my textbooks tell me, the Romans were the first to declare any sort of legal proclamation on the oceans. They declared them as common to all humankind, so a public good. And this is interesting for, like I was saying, for a number of reasons. If you look at the depiction there, I mean, I'm not sure I'd actually want, if the ocean did actually look like that, I'm not sure I'd want to be in a little boat with just a spear. But it depicts an ocean that's highly biodiverse with very large specimens. And also, interestingly for this story, it depicts an ocean that's being fished by a few blokes in a few canoes with spears and small nets. So it's very, very low impact. The ecosystem looks as if it's very diverse and very productive. Now, we would call this common to all humankind. In a more modern language, we'd call this a public good. Now, I just draw your attention to this little matrix down here. It's quite a useful scheme to classify different kinds of resources or goods. So along the horizontal, we have subtractability, and this is the extent to which a resource can be used up. So something that has low subtractability, especially on a day like this, something like sunshine, it doesn't really get used up if people use it. It's not zero because you can shade people, you can get in the way of them. It's effectively very low subtractability. You don't really use sunlight up by using it. So this is subtractability along the top. Along the vertical axis is excludability. And that's how difficult it is to stop people using it. And so this is where the Romans saw the seas. The subtractability was low, and you can see there's lots of fish, there's not very many people, and so they don't really have much of an impact. They don't really subtract from the resource a great amount. And it's very difficult. Lots of people have boats. It's very difficult. You can't patrol the entire ocean. It's very difficult to keep people out of the oceans. So it classifies on the scheme as a public good, a public resource. Now, if we fast forward 2,000 years, we see a very different picture. We see a picture where fish are now extremely or relatively easy to catch. We're very good. We know how to catch them. We can do. These are all just. I could have chosen a whole range of different images. These are just some examples of the kinds of images that sprung to mind. We know how to catch fish. We can do things like encourage them to aggregate with these fish aggregation devices in the open ocean. We can then surround that region with a net. We can pull them up, these sort of Persane type nets here. And this is extremely efficient and effective ways of collecting fish. We're very, very, very good at catching them now. We're also very good at finding out where they are. We understand their ecological niches and their habitat preferences reasonably well. If they're in sufficient numbers, we can find them with sonar and even underwater radar and things. So we're very good at finding where they are. So we can collect them together, we can find out where they are. We have very good boats now. We don't just have canoes and nets. We have these. This has a developed world bias to it, but there are equivalent pictures I could have shown for the developing world. We have very good boats that can stay out for a very long time and are extremely efficient at catching fish. These boats can deliver caught material to these effectively floating factories, these processor boats that can stay out at sea for long periods of time. So it's an extremely efficient process. What we see then is that if we look back at this matrix again of the different types of goods that we can describe, we've really moved from subtractability being low to subtractability being high. So we really can have an impact now. We can take fish out at such a rate that it really does subtract from the resource, rather than just a few blokes and a few canoes taking out something that's effectively has minimal impact. We really can harvest at a rate that's significant. So we really move into this region where we have what we call a commons. And commons can be associated with a whole range of problems. If there is a common resource that can be used up, and there are lots of people available to use it, that can induce a behaviour where there's a race to gather that resource before other people do. And this can lead to a runaway effect where the resource becomes more and more scarce. You have to try harder and harder, so people race faster and faster and faster. And this is the well-known tragedy of the commons, where there's an incentive for, even if the individuals know in the long term it's not in their interest to reduce this resource, if they think someone else is going to get it before they do, then it's still the rational thing to do to go and collect it first. Rational in inverted commas. Okay, so we have lots of potential problems associated with these commons type resources. So I'm going to show you, try and explain one of the very common, well-known examples of commons type problems. We can argue about whether this classifies as exact commons, and there are lots of subtleties, but broadly speaking, it qualifies. This is the collapse of the cod stocks in the 90s, the Northwest Atlantic cod stocks in this region off the Grand Banks off Newfoundland and Canada, where a combination of factors led to the complete collapse of the cod stocks. They still haven't recovered to any large degree. So they went down from their pre-harvesting rate down to about 1% biomass. Now this is a graph here showing time and the catch, and you can see it's already complicated because there's harvesting by the local community, the Canadians, but also lots of people coming from other countries. This is a commons type problem with improved technology. So since the 50s, 60s, 70s, the boats have become a lot better. The technology for catching has become improved. There are also too many boats in the water. The biggest problem here, as in most places where there's overfishing, is too many boats in the water chasing too few fish. We also had, at this time, great political complexity. Again, these problems play out in the real world where political considerations are often very complicated. Lots of vested interests in these systems, both from a social and an economic perspective. So there are fishing communities that have relied on the cod harvest for hundreds of years living in these places. No one really wants to be the person that closes down the fishery, that stops that sort of behaviour. There's an enormous social impetus and social inertia to continue with this kind of activity. Also economic interests, there's big industry involved. The highly capitalised fleet, so people put a lot of money into their boats with the new technology. Again, there's lots of impetus to try and maximise, try and push for the catch to be as high as possible. Given the difficult times, the government stepped in with subsidies, which in some ways is a great thing to do because it offsets the declining returns from the struggling fishery, but in another way, it just amplifies the problem. It stops people going bust so they can continue harvesting at a greater rate for longer. So it kicks the can down the road, but the can becomes a bigger can and becomes a bigger problem. Also add into this uncertainty. So it's actually very difficult. Won't come as a surprise to you. It's very difficult to know how many fish are in the water. We can take samples, or we can make statistical judgments on that. We can understand how the sampling relates to the habitat preferences, and it's actually a very difficult thing to do, and it comes with a lot of uncertainty. So if you're trying to get a reduction in the total allowable catch for any particular fishery, but there's great uncertainty in the estimates of biomass, it can be easily out-argued. Oh, well, your estimates are probably wrong, so we should probably just keep going as we are. All these sorts of things contribute. The reason I'm going through this in more detail is because lots of these things kind of play out in lots of fisheries around the world, and this is a nice example where they happen all at once. And so the result of this, and also I shouldn't forget, and Catherine will talk more about this, the international competition, which again amplifies this commons problem. So if you have people coming from outside, you're worried they're going to catch the fish, you need to go out and catch it before they do, especially as it's a dwindling resource. So the fact that the institutional response to this was relatively weak and relatively slow just amplifies this commons problem. And it ended up with an enormous ecosystem degradation. removal of cod, a huge amount of biomass, and a collapse of the whole system. Possibly, as I've noted here, into a new stable state. So some types of systems, and particularly ecological systems, if you push them into a particular state, i.e. you take something away from them, for example, in this case, and they start behaving differently, if you take away the pressure that was taking that thing away in the first place, they don't necessarily bounce back to where they were before. They can get stuck in operating in a new sense. And that seems, there's some evidence that may be happening in the cod stocks, but there's also some evidence that they're coming back slowly. So the jury's still out on whether it's a new stable state or whether it's starting to slowly come back. But these are the risks that we when we harvest particular parts of an ecosystem, or when we change any system for that matter, any complex system, there's a possibility of pushing it into a different state which can then become latched and become persistent. So that's an example of a commons failure, I think we could probably term it. So how do these things play out across? If we zoom out now from Newfoundland, Canada to the global kind of position, how do these things play out? Well, the UN in 2014, the UN FAO, the Food and Agriculture Organization, released a document. This is an evaluation of global fisheries, saying that about 75% of fisheries globally are either harvesting at the maximum possible rate without causing trouble, or are already tipped over beyond that point into crisis. So this was a very damning report when it came out. We've seen about a 2/3 decline of predatory fish in the last 100 years. There's a very big study, again in 2014. These are the predatory fish, things like cod, tuna, grouper, shark, the things that humans really like to eat, been harvested at this industrial scale. And we've seen a reduced biomass of those top predators. So we're having a significant effect on the fish populations. As I say, this sort of industrial scale fishing has a variety of other knock-on detrimental effects. So there are ecosystem effects and habitat impacts. Just the fact of taking fish can sometimes damage habitats, as we know. There are also subtler effects. So things like when we try to collect fish, for example, in a school here, there are often other things around that are also trying to catch the fish and eat them. And they can sometimes be caught. This is called bycatch, when you catch something by accident that was hanging around in the vicinity, doing its own thing, was caught. There's a shark here caught in the nets. So bycatch is a really significant problem globally. Also, there are more systemic effects. If you imagine a trophic pyramid, trophic structure, and if we're taking the predators from the top predators at the top, the carnivores at the top, if you remove a significant number of those, there'll be some readjustment of the system underneath. So if you release the things that are lower down, this is eating this. If you take the top ones out, the ones underneath are sort of released from the pressure of predation to some extent, and they can blossom. Now, that becomes a problem. This reorganization can potentially become a problem if you progressively harvest further and further down this trophic system, and also across those levels. And in some extreme cases, this reorganization favors things at the very bottom. So the kind of the slimy stuff, the jellyfish and the algae, the things that are more opportunistic and can reproduce at very great rates. So not only the direct effects of taking the fish, but there are more systemic effects on the ecosystem. Now, if we think of that as being one component of this trio, we have overexploitation of living marine resources, so direct effects on the trophic interactions and the trophic structures of these systems. We then stress with additional climate change, so we have temperature effects, changes in acidity, for example, in the oceans. And then we hit the systems also with pollution. You can see that this recognized global decline in the health of the global oceans is understandable in these terms. There's a significant decline. The consensus view is that the global oceans are in serious ecological decline. It's heterogeneous. That's a very sweeping statement. There are places where it's going well, places where it's going badly. On balance, there's a problem due to these factors. So all doom and gloom so far, I'm afraid. A bright spot now. So there are management successes. I don't want to leave you with the view that we manage everything really badly and everything's terrible. That's not the case at all. There are lots of examples around the world of extremely well managed, well understood fisheries. And so this is the same same cod stocks. And if I just go back a couple of slides, so we were talking about these ones over here. The blue shows you where the cod like to be. We're talking about these ones over here now, Norway and the Barents Sea. Now these ones were facing a similar. This stock was facing a similar decline. You can see here the trajectories is downwards, and it was looking as if things were looking bad. But they managed to turn that situation around, and now the stocks have rebounded enormously up to levels that are higher than historical levels. So it's now an extremely well-run, highly productive cod fishery. Now, we haven't got time to go into the details. It's a very sophisticated plan, very detailed, very sophisticated plan that led to this recovery. One thing that's worth noting is that one of the things that was done, and one of the things that was done more, was a kind of a neat sidestep of the commons problem, which is if it's possible to move from this box, if you can make it easy is probably the wrong word in this case. So excludability, remember, is how easy it is to stop people using the resource. And in the commons, it's highly subtractable, it gets used up, and it's very difficult to stop people using it. So like taking logs out of a forest, it's very, very difficult to stop people doing that. If you can carve up the resource and give parts of that resource to individuals, for example, and say, this part of the resource is yours and you can harvest it whenever you want to, you get rid of a problem that's often called the race for fish. So you would think, and it would be a reasonable thing to think, if you have a resource that's a commons and you set a limit on how much can be taken from that resource, that should solve the problem. As long as you set the limit to be something reasonable, it's not too high, that should solve the problem. You're not going to over-harvest because you're setting the limit to how much can be taken. And that should, in principle, solve the problem. The reason it doesn't is because if you set the limit, then it's in everyone's interest to get as much as they can until that limit is reached. So they race as fast as they can to get as much as they can, as quickly as they can, before the resource gets closed, because the resource has been harvested as much as it can be. So that can be very detrimental ecologically. It can be very bad for the safety of the people doing fishing because they feel they need to go out in all weathers. It can be very bad economically because you congest the market by having a glut of product dumped into the market in short time. If you can carve up the resource and give a piece of the resource to individuals and say, over the next year, you're allowed to catch X amount, then they can spread that according to when the prices are high, they can spread it according to when it's ecologically more meaningful to go out and get the stuff. It solves a lot of these problems. So by having a quota system, in some situations where it's enforceable, is a very nice way to solve these kinds of problems. But it's never as easy as that, and there are different solutions needed in different countries, different levels of economic development. There's a whole range of things that need to be taken into account. And the FAO summed it up very nicely here, where they said what's most challenging seems to be selecting the most appropriate management strategy and/or set of regulations that will actually lead to the desirable fishing mortality across the food web. So in broad terms, we know what to do, but actually designing the rules and implementing them in the way that results in that is really tricky because, well, for reasons I'll go into. So let's have a look at how that might work in principle. We have a very simplified sort of little diagram here showing the goals and priorities set at the top by the political, institutional, legal structures. That then feeds into development of policy. So, for example, quota limits, like in the previous example. That then requires implementation. So how do we set regulations, how to enforce these policies, which then leads to some outcomes. And in ideal, the outcomes would be in terms of human behaviour and ecological behaviour, the biomass below the water, for example, in this case. Now, ideally, we'd have some kind of feedback between these things. So what happens, what the outcomes are, will feed back into changes in implementation, it'll feed back into changes in policy, and may feed back into changes in the institutions themselves. Given this, and if this is working well, we'd expect to be able to answer these kinds of problems. These are the kinds of questions we're trying to answer in our project. So what's expected for any given regulation? How would some regulation play out? If we want to achieve something, what would a good policy be in order to achieve that? If you can't impose policies from the top down, so you can't have some regulatory structure that's enforced, how can we encourage solutions from the bottom up, so cooperative type behaviour to emerge? We'd expect to be able to answer these kinds of problems, and these are the kinds of questions we're trying to answer with our project. Now, in the real world, there's constraints to the level to which this is an efficient process, so the success of this kind of process. These feedbacks are are stymied to some extent by a variety of things, by a lack of information. Information takes time to produce, it's very expensive, it requires great expertise and scientific understanding in some contexts. All those resources aren't always available in the places that we need them. So for example, in some rich developed world situations, these feedbacks do work very well and very effectively. In other situations where the resources aren't available, it's very difficult to do this. So what we see is that it's not really, we would want to be able to optimize in some way, to find the best rules for achieving a particular outcome. That's what we'd really like to be able to do. We'd like to leave it up to the system to find it itself slowly over time. That doesn't seem to work. So what's the next best thing? The next best thing would be to do something like run an experiment. So how can we find we can do an experiment on some fishery where we try different things, we do some blind trials. We can't do that. So we can't do it empirically either. We'd really like to be able to do exploration of policy, optimization of different control policies. It's just not possible. It's too slow and it's too efficient, and it's just infeasible in real world complex human environmental systems. So this results in significant management uncertainty. So we really don't know what's going to happen when we implement some policy. We have to just see how it plays out and then correct it if necessary by some means. So we want something better than that. We need a tool that's better than that for solving these kinds of problems. And the way that we're trying to, this is the matrix reference comes in. The way we're trying to do this is to build a computer simulation of the entire system that we can use as a laboratory, as a flight simulator effectively for policy. So we have a system that's modular. It has a representation of ocean ecology at the bottom. We have a variety of models that we can plug in this space. We have a fishing fleet, and then we have a policy layer at the top which imposes constraints and incentives. These full lines show direct effects, and the dotted lines show the flow of information through the system between different components. And then we of course couple this to a market. The fish needs to be sold, and there are signals that come back from the market which direct fishing effort. So we have this system which is a coupling of all these different components. And then external to the system, we have things like climate influences. So over a short term, we have variability, but also longer term, we have possibly climate change scenarios to run. We also have external economic factors. So we have, in a globalized market, for example, we'd have pricing signals coming in from far away. These could be random, they could be cycles, they could be trends, a whole range of different kinds of factors that can feed in from outside. So this is I'd like to talk to you for several hours about the details of this, but sadly it's not possible. So that's the summary of the structure of what we've got. Now, let me just go back quickly. One of the things we're putting particular effort into is this part of it, the fishing fleet behaviour. So we can dream up policies, and we can hope that they produce some outcome in the water and economically in the markets and in the pockets of the fishermen. But really, the policies get filtered effectively as they go through this behavioural layer of the fishermen. So we really need to understand how the fleet will respond to any given incentive, because it's the behaviour of the fleet that really has the direct effect on the ocean. So if we don't get the behaviour of the fleet right, none of it's going to work. Now, this is a list of some of the characteristics that we expect of all human beings, but it certainly applies to fishes. They're interactive, communicating agents. They're heterogeneous in their incentives, in their response to constraints. Some will follow the rules, some won't. Some of them will compete, some of them will cooperate or collaborate. They're able to learn from experience and from one another, and they make friends and break friends like the rest of us do. So they're individually the fishing agents, the people that we can think of the agents as being the boats. We can think of the boats are run by people, but the thing that does the business is the boat. So we can kind of imbue the boats effectively with these kinds of characteristics. What we shouldn't assume, and what has been assumed in many kinds of these sorts of modelling exercises in the past, is that the fishes are sort of Homo economicus type agents. So they're all identical, they have perfect knowledge, they're optimally rational and interested only in profit, and they follow the rules. That's not the case. When you talk to fishermen and when you read the studies and when you spend time with them, you realise that's not how they operate. They're much more sophisticated and interesting entities. So in our model, we model the fleet as a collection of agents. And these agents are represented diagrammatically here. You've seen that. Now, one of the reasons that we want to do that is it makes intuitive sense. I'm just going to run this video while I'm talking. I have to try not to watch it because it's too interesting. Right then. So what happens when we put lots of agents together is often quite interesting and quite unexpected. This is a beautiful video of starlings by Paul Bunyard. You can find it on YouTube if you're interested. When we have individual agents, individual elements in a system that can communicate and affect each other, and there's feedback between them, then that can sometimes give rise to what's called emergent behavior. So the behavior of the individuals, when collected together, is qualitatively different. So the group doesn't behave like the individuals do. So these are starlings. If you populate a computer simulation, there's a very famous one called Boids, B-O-I-D-S, you can find online. If you populate a computer world with birds that have 3 rules, I'm trying to remember these correctly, fly in the same direction as the bird next to you, don't bash into the bird, and if possible head towards the middle of the group. I think they're the rules, but you might find that there's something like that anyway. This naturally happens. This emerges out of that system as a spontaneous emergence of order. And lots of systems in nature and social systems, economic systems, have these properties of self-organization. It's expressed here beautifully in spatial self-organization, but it can be expressed also temporally or in a whole range of different factors. So these structures, there's no single bird, well, it's not necessary for any single bird here to know what the group is doing. There's no bird that's in charge. And if you tried to write the rules for how that apparent sort of entity would behave, it would be very different to the rules of the individuals that make up that big population. So this emergent behavior is something that you get from complex systems. You see in lots of domains. And the interesting thing for us is that it makes what are called complex adaptive systems, where these systems are very dynamic and they're able to adapt to new circumstances. I'm going to stop it now because it's putting me off, but please go online and look at it because it's beautiful. And there's some nice music with it as well, which is good. So now, why is adaptation necessary for us? Well, it's necessary that we have this in the model because fishes will adapt to new conditions, they'll adapt to new rules that are imposed on them. These can be unintended consequences. So, for example, you might think, well, if we want to reduce the amount of fishing that's done, let's just reduce the time that they can go out by half. Seems reasonable. But what happens is they just fish twice as hard for half as long, and you don't really gain anything. And there's an extreme example here. This is the Alaska herring fishery, where the fishery is only open for a few hours every year, and you can see it's just mayhem with this just enormous activity. There are other examples where for example, boats were limited to a certain length to reduce their fishing, the power with which they exert their fishing pressure, and the response was to make the boats a lot wider. And so there's lots of ways in which these things are adaptive, and we really need to capture that. So here's some model results. This is a very simple cartoon world, and I'm going to show you some. These agents aren't. These are very, very minimally intelligent, very, very simple agents. We haven't told them anything about, in this case, fuel prices. You see here there's a gradient. This is the coast. This is the sea. This is the port. You're going to see lots of fishes that look like this. These are little boats streaming out, and it all happens quickly because this isn't in real time. Obviously, it would be very dull to see them trekking across the ocean in real time. This is running time quickly. There's more fish further away from land, but they also have fuel price to worry about. So what happens is, as they leave port, they very quickly work out that there's an optimal point at which to fish, because this balances the extra earnings they get from going further out with the extra cost of fuel by going further out. So what we can do then, and again, we haven't told them anything about fuel. They just learn this. On the job, as it were. Cruelly, then we have a technical issue. I do have a technical issue. So I'm going to close my laptop and see if that'll wake it up. I really do have a technical issue in that case. Right, bear with me. I'll restart it. I'll just tell you about what we're going to find when it eventually comes back on. They don't know anything about fuel price, but as we raise the fuel price, they learn as a group. So one of them will find that if he fishes closer to land, he earns more money. His friends will find out, and they'll follow him and do the same thing. So as a group, they learn as you change the fuel price, they adapt by going closer or further away to land. The other one I was going to show you, I'm just going to wait for this to restart. There's a kind of policy where you have a protected area. It's called a marine protected area, an MPA. And that's a measure to try and protect certain areas that are ecologically sensitive from fishing effort. And so there's lots of discussion about how you should implement MPAs and where you should put them. And one phenomena that you find with MPAs is that the non-protected area gets fished out and the biomass goes down, but the biomass within the MPA stays quite high. But there's a diffusion out of biomass away from the protected area. So let's just get to where I am. So if you fish along the line of the protected area, you actually get a very good catch. So there's a thing called fishing the line, where you fish just at the limit of the protected area because you benefit from the fish spilling out over the edge of it. So it's a very cunning adaptation to a very sensible policy. Here we are. Oh, okay. 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 So I'll just show you quickly that they fish the line. No, I won't. Okay. So we can use the model in a variety of ways. We can decide on a policy in the green. We can run that policy through the simulator and we can see what the outcome is. Sorry, my computer's having issues there. That's one way in which we can run the model. There's another way, and this is the more sort of standard approach. I apologise for this. What's happening with this? Okay. I apologise for this horrible graphic. What the graphic is supposed to show is that we can embed our model within a larger sort of machine, and we can then feed in requests into our machine. So we say, rather than running a particular policy through it, we say, what do we want the policy to achieve? We run that goal into our bigger system, and then the system can then itself spit out a policy. So there's different ways in which we can run this model. Just very briefly, here's an example of how we can decide on how to place an MPA. Yeah. So there are two kinds of boats here: little inefficient ones and large efficient ones. This is quite a realistic, more realistic scenario. The question then is, how do we set up a rule where we can maximise the catch of the total fleet but also protect the little boats? And the policy that we have is the placement of an MPA. You can see this thing here shows that if you put your MPA, if you set up your MPA in a particular state like this, you manage to maximise. You really get a very good score, a very good earnings for the little boats. If you have your MPA over here, looking like this, you get a very good score for the big boats, but not a very good score for the little boats. So this is called a Pareto curve, and it shows you the most efficient solutions to this problem. And it just shows that depending on how you balance up the requirements for either being better to the little fisherman or better to the big fisherman, you need to place your MPA in a different place altogether. So where are we applying this? We're applying this in the US West Coast in California. We're feeding real data into our model. So to actually, rather than a cartoon that you saw before, we're putting real habitat preferences and real fish distributions. We've now got fishermen fishing in California, so we're going to be looking at the policies that they're using in California. How can we improve? Can we think about ways to improve the policies to improve economic, social, and ecological benefits? How can we improve the human dimensions when we're assessing different policies? And how can we look at how robust those policies are to future non-analog environmental conditions? So under global warming, for example, these warm blobs of water that we're finding off the west coast of the US now. We're then moving on to Indonesia, a whole different set of problems, highly complex ecological, economic, technical, and social situation, very different to the very well constrained, very well understood US West Coast, where the emphasis there, rather than optimal yield, is more on broadening the ecological rebuilding. Also, given that there's a lack of data, what data would be best in order to collect to make the best model decisions? So we're guiding data collection as well. So I'm out of time, so I'll just quickly finish by showing you this same diagram again, which shows one of the points I was trying to make earlier on is that that all these problems are highly interconnected. It's very difficult to think of ways to improve fisheries without having a legal basis in which to do it. If you have a legal basis in which to do it, you need to enforce that in some way. So satellite observation is a really key part of that. Deciding where to put things like MPAs or the potential impact of fisheries requires knowing something about biodiversity and distributions of impact. And then we have things like mining that Alex is going to talk about in a moment that plays into all of those as well. So I'll hand over to Alex and he's going to talk about those other components.
Thanks, Richard. So, we've heard about how to improve the policy around fisheries management, but of course the ocean is absolutely vast. So how do you actually implement these regulations in terms of fishing? One of the big complications we have is that essentially states own the resources within what's called the exclusive economic zone, which goes out to about 200 nautical miles from the coastline. But beyond that, we have international waters or the high seas. And out there, essentially, the fisheries resources are the common property of humankind, if you like, and individual vessels are almost little islands of the states to which they're flagged to. As you can imagine, this leads to all sorts of nefarious behaviour. You can see a picture here of this vessel right underneath the noses of the Australian Coast Guard, where they're literally painting out the name of the vessel and running up a different flag to prevent, under international law, that vessel being boarded to check them for illegal fishing. And just to point out that something like 1/5 of all fish are caught by what are called IUU vessels, illegal, unregulated and unreported fishing vessels. Now, the other problem is that once you have an illegal route for something like fish, then you've got an illegal route for all sorts of other bad behaviour. So we see vessels involved in illegal fishing also tied up with drugs trafficking, trafficking of arms, use of slave labour on the vessels, human trafficking, and even terrorism. And the Mumbai terrorists actually came in on an illegal fishing boat which they'd captured off the coast of Pakistan to carry out that attack in Mumbai, which killed so many people. So this is a major issue, not just in terms of managing fishing, but also in terms of global security. Technology is providing some of the answers to what we call monitoring, control, and surveillance of on the oceans. Now, we have a number of different systems which we can look at to actually track vessels at sea. The first two I've got listed up here, vessel monitoring systems and automated identification systems, are effectively satellite pingers. They're transponders on the ship that pings a signal up, which is picked up by a satellite, and then that's beamed back down to a receiving station on land. The problem with both of these systems is that they can be tampered with. So you can basically change the electronic identification of your vessel. You can alter the signal so it seems to show the vessel somewhere where it isn't, or you can just simply switch the equipment off. And in fact, just by looking at the frequency at which AIS, for example, is switched off on vessels, you start to get an index of how badly they're behaving out in the ocean. So we have to start looking at other forms of technology to look for these ships. One that was developed by the military is called synthetic aperture radar. It's basically radar which is carried by satellites, and it produces these types of sort of glowing images on a map. So you can see that there's something there. You can see a wake behind the vessel, so you get an idea of speed and direction of travel, and you can work out roughly how big the vessel is. So this is useful in enforcement terms, but in terms of actually booking these guys for illegal fishing, if they're somewhere where they shouldn't be, that's not a fantastic tool. It will tell you some things there, but it doesn't tell you who it is. This is a different form of data, visible infrared data, and often fishing vessels will use lights in their fishing practices at night time. And you can see a nice example here of lots of fishing boats off the coast of Thailand being picked up by this VIIRS satellite. So this is also useful for identifying where vessels are in some cases. The Rolls-Royce of satellite detection are optical sensors. And here you can see a satellite picture of two fishing vessels transshipping fish to basically a reefer or a freezer vessel at sea. And you could certainly probably use an image like this to actually identify a specific vessel at sea. The big issue is this image probably costs somewhere in the region of £5,000. So economically, these are almost unviable tools for fisheries enforcement under the current structuring by the satellite provider companies in terms of charging people to use their products. So part of our project really is looking at the use of these new technologies in fisheries enforcement. And one of the things we're looking at, just to start off with, is where we can actually get free data from satellites to use in this context. And Gwilym, one of our Oxford Martin research fellows who's working on this project, has started work on this. And you can see here these data from Sentinel-2 satellite. And the interesting thing is that if you look at these data, unfortunately satellites like to switch off when they're over the sea, which is really annoying if you're trying to find fishing vessels. And that's to save energy. But you can see that their land tracks basically overlap the sea around much of the African coast. So immediately we're seeing that there's free data covering a good part of the EEZ, exclusive economic zone, of African states. So this is really useful in the context of just understanding how much illegal fishing might be going on in these EEZs. And of course, we can fuse these data with other types of data, such as AIS, and overall, this fusing of different types of data helps us to identify what these vessels are and what they're actually up to. Another thing we kicked off the project with was actually looking at the use of satellite technology in enforcing a new marine protected area around one of the UK overseas territories. In this case, Ascension Island. These are tiny islands, but they have a huge exclusive economic zone around them, a huge patch of the ocean, which they have exclusive rights to in terms of fishing. There's a tuna fishery to the north of Ascension Island, basically generally operates up here. So traditionally, tuna boats have come down and fished in the EEZ of Ascension in the northern area from January to about May. That's when the main activity is. Now, there's been a push from the UK government to actually declare the whole of the EEZ around Ascension as a marine protected area. Ascension has endemic species of seabirds, many other seabirds which nest on it, and there's a great concern that as peripheral effects of fishing, those seabirds will be harmed and their long-term viability affected. Obviously, there's pushback from the people who actually live on the islands who feel that one of their main sources of income is fishing. So in true British fashion, we've got a compromise where about half of the EEZ is left open for fishing and half is closed as a marine protected area. But how on earth do you enforce this in an economically viable way? And of course, what we've been looking at is the use of SAR, synthetic aperture radar, to actually target a patrol vessel which turns up sporadically in this EEZ towards areas where there are SAR signatures of vessels. And that trial is occurring at the moment. It finishes at the end of May. And the lovely news from this story is we've seen virtually no illegal activity at all in the closed area. And in fact, bizarrely, vessels which have innocent right of passage across these waters, if they're not fishing, are actually steering around the EEZ to avoid going into the protected area. In another overseas territory, this summer we're planning to trial both satellite and what are called autonomous surface vehicles. This is the Autonaut ASV, which is being built in the UK. It's a 4 or 5 metre autonomous vehicle, and essentially we can direct this towards targets which have been detected from satellite. And also we've equipped this ASV with oceanographic monitoring equipment. So what we end up with is not just a tool for enforcing the marine protected area around British Indian Ocean territory, but also a tool we can actually use to monitor the health of that ecosystem, which actually links in with other research we're doing in Chagos at the moment. And our team were out there earlier this year doing work on the coral reefs in this area. So fishing really is a legacy industry in the oceans, but we're starting to see the development of new incipient industries, and the one that's really news on the streets at the moment is deep sea mining. Now, when people think about deep sea mining, they often think about this activity, which is basically trawling for what are called polymetallic nodules on the deep sea floor and hauling them up to the surface and taking them away to land to be processed. Actually, there are quite a number of different mineral resources in the deep ocean. They all occur in very different environments, and so the environmental concerns about those activities are very different in different parts of the ocean. And this is one of the target areas for deep sea mining. This is a deep sea hydrothermal vent in the Indian Ocean, and you'll see coming into picture here, this black smoke billowing out of this chimney. This is at a temperature of between 300 and 400 degrees C. That black soot are particles of polymetallic sulfides. So all of this concretion here has very high concentrations of copper, nickel, gold, silver, and various other metals. And that's why people are interested in mining these things. So what are these vents? Well, essentially they're places where seawater seeps into cracks and crevices along mid-ocean ridges and other areas, comes into contact with very hot rock lying underneath the surface. It's superheated, there's chemical exchanges with the rock, and that's when it takes up all these lovely juicy metals. And this is what the insides of one of these chimneys actually looks like. What you're seeing here is copper pyrite, just layering the entire inside of one of these hydrothermal vent chimneys. And these types of machines are actually, as we speak, being trialled somewhere in the Arabian Sea, I believe, prior to being sent out to Papua New Guinea to undertake the world's first deep sea mining operation in 1,600 meters of water in a place called Solwara 1. As you can see, this machine will simply bust up the seafloor and collect the concretions around these vents, and they will then be returned to the surface for initial processing on a barge and then shipped over to Australia. So we're very interested in the development of this whole new industry. It's really revealed our level of poor knowledge in terms of the deep ocean and raised all sorts of issues about how do we carry out environmental impact assessment in these areas, how do we manage these activities. And this is our main focus area for this work. This is the Indian Ocean, and here, this is on the high seas. The Chinese have got a license to actually explore part of the Southwest Indian Ridge for these seabed massive sulfide minerals. Up here, the Koreans have a license to do a similar thing, and the Indians have a license to explore for polymetallic nodules, actually in the central Indian Ocean here. So we've been working in these areas. This is the actual vent field that the Chinese are exploring at the moment which we got the first film of back in 2011. It's a very interesting hydrothermal vent field. It has some very unusual geological structures, but also the fauna seems to be quite unique in that it seems to be a mixture of Antarctic hydrothermal vent organisms and Indian Ocean and Pacific hydrothermal vent organisms. It's a very bizarre and unusual site. We can't see that too well, unfortunately, with the lights on, but I'll just show you some of the beasties that they... Oh, that's better. I wish that always happened when I asked for something to happen. So you see here some of the organisms around these vents. These are stalked barnacles. This is a new genus and species of snail we recently described. These are vent mussels. Now, if you were in a normal deep sea environment, life would be very thin on the ground. But these organisms actually survive on chemical energy. So bacteria, which they either eat or carry as symbionts, oxidize hydrogen sulfide and other chemicals in this fluid that's coming out of the ground and use that to produce energy, which then drives carbon fixation. These animals here, scalyfoot snails, are the only animals on Earth that make armor out of iron. And they do it on several of the hydrothermal vent fields here in the Indian Ocean. So in February, when you were all shivering here in the UK, I joined this ship in Mauritius and went diving in this vehicle. This is the Shinkai 6500. It looks big, it weighs 27 tons, but the bit which you sit in is actually a 2-meter diameter titanium sphere that's buried in the front of this vehicle. So it's very small, you can see it just here. You've got 3 portholes to look out of. They're about 20 centimeters or so in diameter. And if we drop the lights again. So this is film from actually, which I took actually inside the submersible. We're at about 3,300 odd meters here, about 2 miles beneath the surface. And as I said, there's 3 of us crammed into this 2-meter sphere here, actually hunting around for a new hydrothermal vent site on the seabed. We also visited and sampled a number of the vent sites in the central Indian Ridge, and the first thing I'd just point to here is just how different this system is from those down the southwest, on the southwest Indian Ridge. So even though these are in the same ocean and actually not that far away from each other, physically you've got completely different biology amongst these sites. These are all shrimps, by the way. This is not mineral. These are millions and millions of these chaps, all swimming around. These actually carry bacteria around in their gill chambers, and the bacteria provide them with their nutrition. These weird reflective structures on the dorsal surface are actually where the eyes have sunk back into the cephalothorax over millions of years, and we think they use them to detect the heat around the vent and orientate themselves around the black smoke where they get the most hydrogen sulfide. So we're working on this new industry, but this really brings home a big problem that we have, and that is, how do we gather together all the information that we're actually collecting and turn that into a form that's actually useful to policymakers or even the public in terms of interest. And that's really where the other work package that I'm heavily involved in comes from. This is developing what's called the Ocean Tool for Public Understanding of Science, or Octopus. And Octopus really is a kind of system for gathering in data from all over the place and turning that into a form that's actually useful for somebody if, for example, I want to site a new oil rig or a fishing operation somewhere. What is the biodiversity that's known about in that location, or what is the predicted biodiversity that's in that location? What parts of the ocean are actually undergoing the most change in terms of climate change and so on. These are all questions which we can actually address using this system. Mark Wheeland, another OMS fellow, started work on this about 4 weeks ago, and he's made huge progress in that time. Mark's hiding down there. So Mark gave me this diagram of how this system is now structured. If you've got any questions about that, please ask Mark, because I'm not a GIS specialist. But just to say that he's actually pulled in over 1,300 data layers already for this project. And he's already developing the architecture that will allow us to, really overlay these different forms of data and produce useful products for policymakers, NGOs and the public. We're actually already interacting with other people who work in this area. So, for example, we're undergoing discussions with both the World Wildlife Fund and ZSL over tying Octopus into the Living Planet Index. So this will be really a very useful public communications tool in terms of explaining to people how the oceans are changing. And we're also discussing the co-development of tools for users with the Ocean Biogeographic Information System. And this is a database of all species records that have been submitted to them that was set up by the Census of Marine Life program. Right now, the timing of our project has been really fortuitous because the United Nations Convention on the Law of the Sea is now entering negotiations over a new implementing agreement to protect biodiversity on the high seas. So this tool inevitably is going to be of great use in the context of those new UNCLOS discussions. Okay, so that's all I'm going to say, and I'll hand over to Catherine, who's going to talk a bit about the sort of legal side which binds together.
Thank you very much, Alex and Richard. They've made my task relatively straightforward because they've touched on many of the legal issues that I'm just going to cover in brief. So if some of you are sitting there thinking, oh my goodness, she's going to talk for half an hour, I'm not. This is a short and sharp and sweet, hopefully, and then we'll open the floor for Q&A. But I did want to say just a few things about issues of the Global Commons, which of course is the overarching Oxford Martin School program for our consideration of sustainable oceans management, but from an international law perspective. I don't have slides. I've got one visual aid. I do have a technical glitch, a broken hand, so I'll hold it up with my left hand. From an international law perspective, Global Commons refers primarily to areas beyond national jurisdiction. So the high seas, we might also refer to outer space and the Antarctic query. Not the moon. The moon is not a global commons. It's in fact the common heritage of mankind. So in a Sunday newspaper recently offered as a unique Christmas gift title to part of the moon, you couldn't appropriate the moon to an individual, so it was a waste of money. Nice idea, good certificate on the wall, I suppose. Similarly with the high seas, or with respect to the resources of the high seas, you can't get a certificate of title. They're not owned by anyone. And that is one of the characteristics of common areas and common property resources, is that they're not subject to appropriation unilaterally by any one state or to the exercise of exclusive sovereignty by any one state. So they are open to everyone and not susceptible to occupation or control by an individual state. It goes hand in hand with that property or that characteristic that equally there is no right to prevent others from joining in that exploitation of common property resources, absent express agreement to do so through treaty or other arrangement. Now, as Richard indicated to us, we can trace right back to the Romans the notions of common property. But the notion of the global commons, the high seas being free to all, is actually intricately linked with the development of international law from the 17th century. And here comes my visual aid. The so-called father of international law, Hugo Grotius, a Dutchman, wrote a famous tract, Mare Liberum, in 1609. Mare Liberum, the Free Sea. But it had another title. The alternative title was a dissertation on the right, which the Dutch have, to carry on Indian trade. So this was a treatise to justify seaborne colonial trade, and at that time, most of the oceans would have been considered open, the high seas, in Grotius's conception of it, and only a very narrow band. So if we think of the colourful map that Alex showed us of all those exclusive economic zones, that's 200 nautical miles. You would have been fortunate to have 3 miles, perhaps, back in the 17th century. But equally, as that Roman depiction of the resources of the oceans demonstrated, the need to exclude, to put the time and energy and resources into exclusive appropriation of resources wasn't really considered necessary because those resources were so plentiful, whether it was the living resources of the oceans or indeed their assimilative capacity when it comes to pollution. Chuck things in the ocean, they're big enough to assimilate. What's the problem? We don't need environmental regulation. So the central concept here was freedom of navigation and fishing apart from that narrow coastal belt. But the central legal implication of the status of an area as common or of a common property resource is this notion that all states have access to it and that they're entitled to exploit its resources. And there was a famous arbitration in 1898 involving fur seals. In the introduction, we talked about fish without a passport. Well, can you say that seals have a passport, that they're British or Canadian because they started on land and went out to sea? Or do they become a common property resource once they go beyond that territorial belt of the territorial sea where there is sovereignty, and suddenly they become a common property resource? They have no passport. They belong to no one, but are susceptible of appropriation through fishing and other activities. Well, the Bering Fur Seals arbitration in 1898 said, in fact, that seals and other living resources of the oceans are free access once they get within that high seas area. So you needed treaty arrangements for the key states involved in the fur seals economic activity to agree on rules. How did you agree on rules? Well, think about one of Richard's boxes about the structure of the market. Fur seal pelts were all processed in London, so the UK had leverage in getting all the parties to the table to agree rules on fur seal exploitation, at least temporarily. So unless that free access is regulated by treaty or other arrangement, as it was in that fur seals example, there is the potential for the tragedy of the commons and overfishing and overexploitation and biodiversity loss. And then the possibilities for legal challenge are very slim, because if no one owns the resources on the high seas, who is suffering an injury if individual states exceed in their fishing capacity or their fishing efforts and cause overexploitation? Unless we can argue that there's a general obligation owed to the community as a whole sustainably to harvest fish on the high seas, and there isn't, or that you're causing some kind of significant harm to the environment and the ecology of the high seas, it's very difficult through ordinary rules of international law for individual challenge to take place. So again, that's why we need treaty arrangements, including cooperation on enforcement. This is exacerbated, this global commons issue, by the fact that not only are the resources not owned by any one state, but also the fact that in terms of exercising legislative enforcement jurisdiction, so who regulates those fishing vessels on the high seas? It's the flag that they carry, which may change in the course of the voyage. It is the flag state where that fishing vessel is registered that exercises exclusive jurisdiction over the vessel on the high seas. So no other state, no matter how ecologically minded or whose economy is suffering because of overexploitation by that flag state of a particular resource, it cannot actually board or arrest that vessel on the high seas, absent express consent or a treaty arrangement for doing so. So if the resources aren't owned by anyone, and we also have the fact that flag states, some good, some bad in terms of conservation, are the only ones who can take action against their own vessel on the high seas, absent treaty cooperation, it's a lethal cocktail that leads to overexploitation and biodiversity loss. When we add to that fact that my subject, though dear to my heart, lacks a centralized lawmaking and central enforcement capacity, the generation of international rules of these treaty arrangements relies on states identifying a problem and agreeing to address it, whether through a regional fisheries organization or, as Alex has just mentioned, the current negotiations with respect to biodiversity in areas beyond national jurisdiction. But if we step back from the high seas, we're not in the days of 1609 when the high seas extended almost to the coastline. Today, as Alex indicated on his chart, his map, most states claim a 200-mile exclusive economic or exclusive fishing zone. So that has taken out of the common property regime the vast majority of fisheries resources that are within those 200 nautical miles. And now you do have excludability. But you have new problems. That doesn't mean that illegal, unreported, and unregulated fishing has gone away. Not all states have the capacity to enforce. If one single satellite image costs £5,000, how much does it cost to have conventional Coast Guard patrols? And so on and so forth. Very difficult issues. And of course, not only is it a resource issue within those 200 miles, but fish don't know where the lines are. They're ecologically arbitrary. 200 miles is a distance criteria, and it's not a geologic or ecologically relevant boundary, is it? So we have the problem of straddling stocks. Oh, I'm a salmon in Canadian waters, and British Columbia spent loads of money on fish ladders so I could spawn and have lots of progeny, and the US fishers just sit on their side of the line, and the salmon zooms across the border, and eureka, cheap salmon. Sorry, I'm Canadian, so good story to tell. There is actually cooperation, I should say, between these two friendly states, but it's an example of the ecologic arbitrariness of those lines. And even worse, what if those fish go outside the 200-mile zone? They go from being subject to the exclusive sovereignty of the coastal state, which includes excludability, to suddenly becoming a common property resource. So you saw that example of Canada and its northwest cod disaster off the east coast, and the plummet in cod stocks by 1995. Now, they closed the cod fishery within the 200-mile zone, which caused significant hardship in Newfoundland in particular that's very dependent on the cod fishery. And if you want the history of this, by the way, there's a book called Cod, a biography, let me get the name right, a biography of the fish that changed the world. We had cod wars and the significance of cod to the Newfoundland economy as well. So it's by Mark Kurlansky. And if you think a book called Cod is boring, it did get the Glenfiddich Award for food literature. So it is actually a good read. Anyway, to come back to the example of the decline in the cod fishery, there was nothing Canada could do about any fish outside of the 200 nautical mile zone unless it was party to a treaty arrangement, as it is, the North Atlantic Fisheries Organization, and that organization has effective enforcement. Now, in 1995, a case came before the International Court of Justice where Spain complained of excessive exercise of enforcement jurisdiction by Canada, not with respect to cod, but with respect to turbot. So Spain was fishing turbot outside of the 200-mile zone, and Canada sought to take enforcement action against a Spanish-flagged vessel. Now, it was on the high seas, exclusivity of Spanish jurisdiction over the vessel. Canada had no enforcement jurisdiction beyond those 200 nautical miles. It was ultimately resolved through NAFO with the EU exercising exclusive fisheries jurisdiction, although the actual illegal arrest was subject to proceedings between Canada and Spain. And incidentally, in solidarity with their Canadian brethren, Cornish fishers, who didn't like Spanish incursions on fisheries within the UK, flew Canadian flags alongside their Cornish flags as this case was pending. Unfortunately, the court held it didn't have jurisdiction, so we don't have authority on the point raised there. But my point is this, that in terms of cooperative arrangements for fish that either straddle national boundaries or highly migratory, like the tuna that we heard about in the British Indian Ocean Territory, they're not going to stay within the EEZ. They're going to go out on the high seas. They're going to go into other EEZs. So you need to have effective means of regulation and of enforcement. And so we have regulatory fragmentation, we have regulatory gaps in terms of effective enforcement, and last but not least, the largest gap we have, and I will finish on this point, is that when we get onto the high seas, we have no legal regime for the protection of the ecology through marine protected areas or the biology of the high seas, the biological diversity. So when it comes to environmental protection of the ecology of the fishers, not only do we have common property issues with respect to the fisheries themselves that needs to be regulated through treaty arrangement, but also the biodiversity and environmental management of the oceans. So our project, we hope, is very well timed in terms of feeding into those negotiations for a further implementation agreement, and stressing the need not just to establish rules and standards, but their effective enforcement, and effective enforcement using a technology which, especially on the high seas, may be the only game in town. Conventional Coast Guard enforcement in the middle of the high seas is a non-starter, but maybe satellite imagery will give us a head start. Thank you.
Okay, we have just over 10 minutes for questions, so not long. Do the three of you want to come on stage so everyone can see you? And we'll use your lapel mics, so don't worry about the lectern. Can I just gauge interest in who wants to ask questions, because we're really going to have to pack them in. So we've got one in the middle there, and one here to start with, and then we'll see. Do you want to take all three of them and then like this? Or do you want to do them one by one?
All three, maybe.
Yeah, one by one.
One by one. Okay, you go first, and then we'll come up here, and then we'll come here.
I guess the biggest, first of all, thank you very much for all of that. I guess the biggest question is what you think the new implementation agreement could possibly look like, and how you would solve issues of fragmentation in organizations that currently exist, IMO, ISA, and goes on for hours and hours. Do you think it should be regional or international? What's going on?
Right, well, shall I start with that? It's an excellent question. I think it's early days. We're just in the PrepCom, and that will take 2 or 3 years, and then the formal negotiations for the agreement will take place. And estimates range from an optimistic couple of years to a pessimistic 10 years. It took nearly 10 years to negotiate the Law of the Sea Convention itself. I think some of the key issues underlying it will be the legal nature of the resources. We saw those deep sea vents with the living resources. So we have a deep sea bed with the non-living resources covered. We have the high seas with the pelagic fisheries. But there's a big debate about whether those organisms we saw, the albino shrimp cooking in the hot water, made me think about dinner, are actually part of the seabed and the common heritage of mankind, or are they subject to this common property resource? And then there is, of course, the EIA and protected areas management. At the moment, we don't have protected areas on the high seas as a permanent solution. Some regional or species-specific regimes will do temporary closed areas. There's been an attempt under some regional arrangements, like for OSPAR in the North Sea and Northeast Atlantic, to have marine protected areas over some of these seamounts. But they need to negotiate not just with the coastal states, but with the International Seabed Authority if this is seen as trespassing on the seabed. So it isn't just regulatory fragmentation between coastal states and areas beyond national jurisdiction. There is also that institutional fragmentation. It's a source of great frustration, but I was at a meeting in Singapore a few months ago, and it is quite striking to see the institutional entrenchment that takes place where individuals say, oh, that's a seabed authority issue. No, that's the IMO. No, the FAO should be doing that, when in fact you need cooperation amongst them. And that's very difficult. And I don't mean to trivialize it, but if the IMO is in London, the FAO is in Rome, and the International Seabed Authority is in Jamaica, it actually makes it physically difficult. Okay, Skype makes things easier, but we do have that fragmentation. And the possibility with the implementing agreement is that you do get some overarching rules and principles that can then be trickled down to these different institutions, but also, of course, to states for implementation. Sorry, that was a bit long-winded.
Yeah. Maybe I'll add a little bit to that. We recently completed the Global Ocean Commission here in Oxford, which was based at Somerville. And there was quite a strong view that there really is a need for some form of oversight body in terms of trying to actually push the various UN agencies and implementing agencies into doing their job. And really to make that happen, I think something like I don't know what you'd call it, a deputy secretary for the oceans or a secretary for the oceans, I think is really needed. The UN General Assembly has been effective at pushing some of these organisations into action. In particular, I was involved in negotiations around developing guidelines for deep sea bottom fishing on the high seas. Their FAO were really slow and dragging their feet over really bringing in these guidelines. There was huge ecological damage being done by these fisheries, and the UN General Assembly basically said, you know, you guys have really got to sort this out, and they brought them back to the table again and again over subsequent years with follow-up resolutions from the UNGA, and that did happen. So it was quite an encouraging example of the way things can work.
Is this on? Yeah. So you said that most fishing is either unsustainable at the moment or on the border of being unsustainable. This is probably a bit of an unfair question, but in your professional judgments, how long do you think it will be until that's reversed, until we can go into the supermarket as consumers and be confident that actually we're not contributing towards that problem, that the fish we're buying is sustainable?
Shall I say something about that? At the moment, we're in a situation where fisheries around Europe and the US, Canada, Australia are being stabilised. So yes, they're being stabilised at 30% of their virgin stock biomasses or whatever, so at a low level, but definitely improved management practices in the developed world has had a significant impact on the sustainable management of fisheries. And Richard showed a great example of that with the Barents Sea cod stock, where there was a lot of illegal fishing going on and all sorts of skullduggery with, you know, vessels under, you know, strange ownership and so on. That was sorted out. What looks like an ITQ scheme was brought in, and that fishery was stabilised. And we've seen similar things with some of the herring fisheries as well. Unfortunately, through much of the rest of the world, that is not the case. So overall, we're still seeing a decline in fish catches, catch per unit effort, and a decline in the state of many stocks. Is that going to improve significantly in the future? I would say probably yes, because many developing states are realising how valuable those stocks are, both in monetary terms and also in terms of employment of their people, livelihoods. How can we be confident that we're buying, you know, sustainable fish? Well, there are market-based schemes, with eco-labelling schemes, which actually are, you know, quite a good guide to whether those fish are caught sustainably. There has been controversy over some of the decisions made under those labelling schemes, and we're in a situation at the moment where there's no common standard amongst those labelling schemes. But I think certainly for, you know, if you're actually looking at what you're buying, it's quite helpful, you know, in terms of trying to make those right decisions.
And not just a common standards issue, but I'd add the absence of a legal obligation to require it by states and through states, supermarkets and the like. And this is a hot button topic. Do you have compulsory labeling? And in so doing, does that actually cause market barriers? So we have the famous tuna shrimp case, and one of the aspects of the case was labeling as dolphin friendly. And whether that has the effect of partitioning the market. So you may seek to do something from an ecology hand, but there may be the trade aspects that you also need to look at. So actually, further fragmentation.
Yeah, in ecology terms, that wasn't great either.
No, true.
The only thing I can add to, like they said, pretty much, but the only thing I can add is illegal fishing is a really big barrier to that, and traceability is one of the key issues. Traceability is a really difficult problem to solve because it's a long value chain. It's technologically very, very difficult. There are some excellent efforts being made to improve traceability, and it is working in some contexts. But once that really takes off, I think that will help to put an end to the impact that illegal fishing, which is highly destructive and has a really big impact on socially, economically, and ecologically, has a huge impact. So if we can deal with the traceability issue, that will go a long way to pushing that agenda forward. But as to how long it'll take, it's extremely difficult to say.
Yeah, I mean, there are market-based and port-based measures which are being put in place as well, which help with this. And also things like the US, is it Magnuson-Stevens Act, where if you're caught dealing in fish which prove to be illegal, you're prosecuted. So even if you're way down the marketing chain, you're still liable for prosecution. And that has made a really big difference to the sustainability of the entire fisheries supply system.
Given that fish stocks globally are declining overall and population is increasing, it seems to me evident that what we have to try and do is not just stabilise at 30%, but try and repeat the Berend example globally. And the question that I would like to say is, has anybody looked at some of the examples of forest management where traditional populations have been dependent on the forest, and then they give them, you have to address their economic needs to prevent them, or not to prevent them, to discourage them from then continuing to use the forest resource. So, I mean, it seems to me that the poacher turned gamekeeper approach might, whatever you do, it's going to cost a lot of money, but the economic value that is being lost every year must be enormous. And so that if even a fraction of that was used to pay fishermen to monitor fish stocks, to observe other fishers, illegal fishing going on, to protect their own futures, that might be a way forward. But is anybody doing anything like that?
Well, I mean, it's interesting what you said, that the Sunken Billions report by the World Bank suggested that the loss in economic terms from poor fisheries management was $50 billion per annum. And actually, they've just revised that report, and that figure has gone up dramatically. I can't remember what it is. Yeah, 70 or 80 billion now, they estimate. There were certainly in traditional societies, you can think of places like Bermuda, small island developing states in the Pacific and so on. There were sort of rights in terms of not rights to fish-specific stocks, but to fish in particular areas around the island. So some areas were taboo, some areas, you know, only the chief or who he gave permission to could go and fish. And effectively what those were forms of marine protected area. So areas which are set aside from fishing and which actually help sustain the fisheries around them. And the reason for that is not just because you're catching less fish, it's because within those protected areas, the fish grow bigger, so you're maintaining the natural population structure of those fish stocks. And of course, big female fish produce magnitudes more eggs than smaller female fish. So that's a very important phenomena in terms of the overspill effects of these protected areas. There has been work done recently by a chap called Costello, who in fact I think you're working with, aren't you, Richard, on this project, where he calculated what would happen if we shut all of the high seas to fishing. So that has a number of effects. One, it reduces fishing pressure, and they estimated that the amount of fish you could catch would go up by, well, up something like 130%. I can't remember the actual figures. But the other neat thing about it is it forces developed states with these fleets of really large ocean-going vessels to have to pay for permission to go into the waters of developing states and fish that resource. So there was a double benefit there. One, just a straightforward increase in fisheries production and sustainability, but two, actually a more equal division of the proceeds from fishing amongst states. And that type of, modelling study, some of these studies really are showing that there are strong ecological and economic, social economic benefits to, putting in some of these spatial management measures.
I'm really sorry, but that is all we've got time for today. It's such a complex subject, and I can see that we'll return to this and have individual seminars on each area of work at some point in the future when you're further down the line, because there's so much to explore, and I think we all appreciate that it's been difficult to pack everything in today. So before we thank our speakers, I just want to remind you that next week's lecture in this current series is from our Integrating Renewable Energies team. So please do come along to that. It's going to be brilliant as well, even if the weather's sunny. I can't tell you how much we appreciate you turning up, even though you could be sunbathing outside, so that's brilliant. And a very quick reminder as well that on Monday the 16th of May, our director, Ian Goldin, will be talking about the pursuit of development. I heard him speak at the Oxford Literary Festival on this. It's his latest book. Really great talk about how sustainable development across the globe has to be rethought, what we need to take into consideration with the introduction of the Sustainable Development Goals. So I highly recommend registering for that. It's going to be very popular. We obviously have heaps of other events, so please check our website. But for now, let's thank Catherine, Alex and Richard. It was a brilliant talk.